before you start to program, it's probably worth making an overall plan. You need to think about what happens in the game and think about all of the pieces that you'll need to add to your code and the locations you'll need to add it in. So I want to kind of walk you through that thinking process right now. So we know that the game needs to be initialized this way, and that initialization is going to happen inside the game board. So let's start to do that. Rather than writing real code, which would take a lot of time and thinking, the whole idea of this pre-planning is we want to write down the goals that we have in English so that we don't have to worry about the code. So here I'll write them down in comments. So add player 1 piece in upper left and lower right, and then add player 2 piece in lower right and lower left and upper right. And I think that's it for the game board initialization. All right, so let's think about move. When I make a move, there's a lot to think about. But the first thing we want to do is catch cheating or catch invalid moves. So I'm going to add some little arrows here, or some graphical elements to make a section. So detect invalid moves is the first thing that we want to do. And there's a lot of ways that somebody could give us a starting row and column and a target row and column where those sets of numbers don't actually define a move that's okay. So let's think about the things that we'd have to check. The first thing that we have to check, that's the most basic thing, is the start location in bounds? Is it even in the grid? Is the target location in bounds? Is it in the grid? Let's think about what else would be illegal. Let's see, I'm player 1, so one thing I might try and do is click on the other player's piece. Or maybe I'd click on a square that's not my piece at all as the starting. So I think one thing I have to check is that the starting place I clicked on is actually my piece. So let's do that. Is the starting location the same as the current, or does the starting location contain the current player's piece? Does start location contain current player piece? Another thing is I have to move it to a location that's valid. So the location can't be too far away. So is my ending location within 2 rows and 2 columns of start location. And then I can't move my piece directly on top of an existing piece. So is the target location empty? So that's all the stuff that I need to check to make sure that my move is valid. So if my move is not valid, I probably just want to exit immediately and return false. If my move is valid, then I actually have to make the move. So let's add a section for that. Make the move. So how am I going to make the move? Well, the type of thing that I do depends on if the move is 1 square away or 2 squares away. So I guess I'd say if target location is adjacent 1 square away, then I want to place current player piece at target. And that's it. I don't want to touch the piece that exists at the starting location because remember, we're cloning our piece. So if I just place a new piece at the target, it'll leave the old piece untouched. Otherwise, it must be that I'm making a jump move. So in that case, I want to place current player piece at target, but I also want to remove my piece from the starting location. So I want to put a 0 for empty space at starting location. All right, so this is feeling like an okay plan. I'm going to detect whether my move is valid. If it is valid, I'm going to make the move, but depending on what type of move it is, I'm going to do something slightly different. Oh, but then we have to think about that last piece of it. How do you actually infect your neighboring squares? So after I've placed my piece, the last thing I need to do is the infection step. So check locations up, down, left, right, and diagonals. And then for each location, I want to say if it's, I got to make sure it's safe to check, right? Because if I put my piece in an edge spot or a corner spot, I don't want to look up off the grid. So if the location that's my neighboring location is in bounds, and it contains the opponent piece, then I want to put my own piece there. Put current player piece in that location. All right, does that make sense? So let's go back and think it all through again. I detect if the move's valid. If it is, I make the move and then do the infecting. So this type of, so I don't know if you have worked on a project that's large enough that you need to do this type of thinking, but this pre-planning is absolutely essential to being a successful programmer on larger projects. Because if you just dove into starting to code, you wouldn't have thought about the shape of your whole program. And you likely would have forgotten certain pieces. You probably would implement certain pieces in an inefficient way. So starting to think your way through what things need doing and where should they happen and what's the overall shape of your program is a great way of making sure that you're going to be successful. That shrieking in the background is my 2-year-old. She's probably fine. So is game over is the last thing that we've got to think about. So I'd said that there's a couple different ways that the game can be over. So we want to check if player 1 has no pieces, then I'd return true because the game is over. If player 2 has no pieces, then I'll return true because the game is over. If there are empty locations left and player 1 and 2 both have pieces left, then the game is not over, so I'd return false. Otherwise I'll return true because player 1 has pieces, player 2 has pieces, but there are no empty locations left, they're all filled, and so the game's over because the grid is full. In fact, maybe we could do this. Let's move this up here. So if grid is full, no empty spots, then I'll return true because the game is over. If player 1 has no pieces, the game is over. If player 2 has no pieces, the game is over. Otherwise, the game isn't over. Yeah, that seems very clean. Probably we don't just want to decide if the game is over, though. Probably we want to know who won. So let's add another method called getWinner. And here we can say, if the game, if game isn't over, winner is 0 because like it's not player 1 and player 2. But if the game is over, then count player 1 pieces, count player 2 pieces, return 1 or 2 for whichever player has more pieces. Okay, so that seems like a coherent plan. Is in grid we did in the last game. Oh, you know what we've forgotten? We've forgotten inside move to switch whose turn it is. So at the very, very end, after the player is done, then we've got to switch player turn. All right, I think that seems like probably a complete plan, although it's very easy to forget things. So implement this in steps. Test it as you go. Think about how you could add the smallest new feature that you could then go back and verify that it was working, because you don't want to try and program everything and then only test at the end, because that's likely to lead to bugs that are very difficult to find. I hope this was helpful. Good luck in your implementing. Start early. Come to help for office hours. Email us. Thank you very much.